Hi. So I've been speaking to Altair, and they were generous enough to give me a free license to their Altair suite of software. Now it's not indefinite, it's for a limited time, but I get to use their different software. Now I want to especially focus on Pollex because Pollex is a really cool tool that I can use to do some analysis on my PCBs. So for instance, when I pulled in a PCB from Altium, I was able to just pull it in and import the design file and be able to analyze the crosstalk. So this is very powerful because with my current designs, I need to look at crosstalk, signal integrity in general, also IR drops and whatnot. And I use certain tools already, but it's just nice that Pollex makes this really easy to do. Let me show you how I did this. What I went ahead and I went to file, import any of these files here, and I just go to Altium Designer and pull in a PCB document. Now the thing is, Altium Designer, when I save the PCB file, it needs to be in ASCII format. That's fine. I can do that, and I was able to import this board from Altium. Now, how do I analyze the crosstalk? I ended up needing to save it as a project, which is very important. You can't analyze it unless you save it as a project. And then I was able to figure out which signals are causing problems for which other signals. So you typically have aggressor signal traces that can cause coupling or crosstalk. Well, can cause crosstalk on victim traces via coupling. So crosstalk analysis is here. This is really good. And then I can just select all of my signal traces like that, and then find coupling. Then it tells me which nets are most coupled with which other net. So for instance, the ground plane or the ground net is mostly coupled with SPI2_CS and so on and so forth. That's super convenient, but I can go beyond that. So what I can do is display and analyze the coupling, zoom in, and really look at what's being affected. Then run my analysis. And it takes a little while to do, but I at least get to see what actually is going on in the signal traces in terms of reflections and what the signals actually look like. Being able to simulate this before I send this board out for fabrication is really helpful because I don't have to wait until the board comes back to see these crosstalk issues on my oscilloscope. So we're just going to let Pollex take the time it needs to. It's doing a lot of calculations and whatnot. So I'm going to go grab some tea and then come back. All right, so it is done doing its crosstalk analysis. And this looks really good. It did the analysis for all of the signals and for the major chips. And it groups the signals too. Man, that's crazy. All right, so here's the thing, right? Why is crosstalk so important? Because crosstalk, well, first of all, crosstalk comes from when you'd have your regular telephone lines, you put them on the handle and whatnot. And I don't mean the digital lines. I'm talking about like rotary phone to dial the number phone. And this is what I grew up experiencing, where I pick up the phone, have a conversation with my friend, and then I could hear the neighbor talking. I could hear the neighbor conversation as well. It would be very faint, but what happened is that the signal lines were close enough for the telephone wires that I could hear their conversation, and that's what we'd call crosstalk. All right, so that gets transferred to here because you have certain aggressive traces creating a magnetic coupling effect onto victim traces, and then those victim traces are cross-talking with the aggressor traces. That's not good, especially if our victim traces need to carry very important or critical signals. We don't want the wrong information on there. How do we solve these kinds of problems? Well, I would use this information to figure out what are my most strongly coupled are signal traces, the ones that have the highest amount of crosstalk. And then I would isolate those and make a plan in my head to move this trace further away from its its aggressor trace, right? And then just update my PCB manually and then resimulate and try again. Okay. So yes, I would need to import it into the POLX software again, but at least it gives me some quick insight into what traces I need to space further apart, or if I need to look at other techniques to reduce coupling for those specific traces. This means I don't need to be a signal integrity expert or anything like that, although they are very much appreciated. But myself as a PCB designer, I don't have to be some advanced SI expert or know about S parameters really to figure my way out through a design and get it done right the first time, right? I can iterate through this process and resimulate until I get the results I want, then send my board out for fabrication. All right. This is really cool because using this technique, using this iterative method for analyzing signal integrity, this goes into sort of the DEPC framework, right? So the DEPC framework, if you don't know what that is, it's not unique in the individual topics, but it's my framework that I've created for design for excellence, EMI, power integrity, and signal integrity. And this would be a signal integrity issue that you would solve through software, right? I very much believe in using software to solve all of our PCB design issues before sending out the board for fab, right? Because I don't want to waste money and do a bunch of extra cycles. I want my board designed right the first time. So in the DEPC framework, signal integrity, this comes under that, and this would be crosstalk coupling analysis, so on and so forth. You can do other things in this software tool like automatic DDR bus analysis, net topology, waveform viewer, and power integrity. That's why I like this software tool, because then I can select specific nets that I want for my power, let's say ground, and then your voltage nets like VCC3A. This one here is a good option too. And then you could like set your model names and all that stuff, set your driver pins, and do some analysis on your design. I won't go into it, but this software is very powerful and helps me review my design and make sure it works. All right, thanks so much. I only really wanted to cover a crosstalk and coupling in here to show you how cool it is that it lets me see all of the crosstalk in my design traces. Very helpful. If you like this video and you'd like to see more videos about the POLX software and different software from Altair, especially for PCB design, feel free to leave your comments and your feedback in the comment section below. Also like this video so others can see the video as well in case they're looking for alternative software to simulate their printed circuit boards and to verify their designs so that they get it right the first time. And finally, if you want to make sure you get updated on all the videos that I do post as soon as I post them, subscribe to the channel and you'll get the notification immediately. Oh, but you also have to hit the notification bell to get that notification as well. All right, thank you so much for watching. POLX is super fast and easy to use too. Like I didn't have to go into the manual like that to understand how to use it. And it also, check this out, it also has thermal analysis. So I'll be using that. You'll see more videos about it. Thank you so much for watching. Peace.